All right, we are going to be starting Module 6 today. This is going to be Lesson 1. We're going to do a lot of definitions today and vocabulary words to start us off with this module. So the first thing that we're going to recall from previous years is how to label an angle. So I'm going to just draw an angle so we have a reference point here. And you should do the same. Now, sometimes you'll see angles labeled like this. There will be a little arc there, and it will be labeled with either a letter or a number. If we're labeling by the arc, we would call this angle B. Now, notice how I put the angle mark in front of the letter. That's just saying angle B. So if we're talking about this angle right here, we could call it angle B. Now, I'm going to draw another angle. I'm going to label this a little bit differently. Sometimes you'll see it like this, and it will be labeled with 3 different letters. And notice that the letter at this point right here, we call this the vertex. So the vertex is that point where the 2 rays come together. If we want to call it by the vertex, we would say angle A, whatever letter is at that point. Now, let's use that same angle where we have 3 letters. Okay, this angle, we could call this 2 different things. We could call this angle BAC, or we could call it CAB. Now, there's only 2 ways to name this angle because this vertex has to be the center letter. So notice that A is in the middle. We cannot call it ABC because B is not the vertex. I like to just say, just trace the angle, CAB or BAC. It doesn't matter which way you go. All right, so now that we've talked about how to name angles, now we don't have to say that angle over there. We can actually use a name. Let's talk about different types of angles. All right, the first one we're going to do is adjacent angles. Okay, the word adjacent means next to. So these are going to be angles that are next to each other. These types of angles share a common side. So they're next to each other and they share a common side. So if you look at this picture over here, we have BAC and we have CAD. Those 2 angles are right next to each other. This is the common side right here. So they share a common side. So the 2 angles that are adjacent, I'm going to name them BAC, this angle right here, and the lower angle CAD. All right, vertical angles. These are angles that are across from each other. So in this picture, we have 2 angles that are across from each other. You know what? For this lesson, I think sometimes it's easier to see this color-coded. So if you have like colored pencils or highlighters, I'm going to grab some myself. If you have them, it might make it easier to see. Let me grab some colored pencils. Actually, I'm going to grab highlighters. All right, so here's one of the angles. So DCF, that's one angle. And the angle that's directly across from that will be GCE. Notice they kind of form an X. So the angles that are right across from each other are the vertical angles. Let me write that down. The orange angle was DCF, and the blue angle was GCE. We could also refer to their arcs if you wanted to say angle A and angle B. That's just using their arcs. Now, one unique thing about vertical angles is that they will always be equal to each other. So in this case, angle A and angle B are equal to each other. All right, angles on a line. These are angles on a ray that forms a straight line. So if you were to take a sheet of paper, you could see that obviously a sheet of paper is a straight line. If I were to put that up there, see where the yellow sheet of paper is? That forms a complete straight line. So there are two angles here, and I'm going to highlight them again just so you can see them in color. We have this angle right here, and we have this angle right here. Those two angles, if I hold my sheet of paper up, notice that the blue and the orange at the bottom just go on one continuous straight line. So that's what I mean, they form a straight line. Together next to each other, they would go right along the sheet of paper. So we know a straight line to be 180 degrees. So what I would be telling you is that these two angles form a straight line, meaning they add up to 180 degrees. Now, the two angles that I'm talking about are angle ABC and angle CBD. Now, I just told you they add up to 180 degrees. So what I would be saying is this angle, this blue angle, plus the measure of the orange angle together would be 180 degrees. All right, angles on a point. These are angles with the same vertex. That add up to 360 degrees. So here's your point. There, in this picture, there are three angles. We have angle A, which is right here. That's my blue angle. We have angle B right here. And let me grab another color for angle C, which is this angle right here. So notice A is their vertex. They all share the same vertex. And they form a complete circle. It goes all the way around. Now, what we know about circles is that they add up to 360 degrees. So I'm going to say that the three angles are angle B, A, D. The orange angle is angle B, A, C. And the third angle is angle C, A, D. And like I said, what we know about them, that if you add all three of these angles up, angle A plus angle B plus angle C, you're going to get a complete circle, which is 360 degrees. All right. Next page. So let's put those vocabulary words into practice here. We have a diagram, and it says that we're going to name angles that are vertical. So first thing we want to do is find angles in this diagram that are across from each other. Now, they have to form an X. That's what I told you before. So an angle that is across from each other is not 79 and 37 because those would not form an X. It would not go straight through. So which angles would form an X? I noticed that this line goes through and this line goes through. So there's my X. So the angles that are directly across from each other are the vertical angles. Notice that those vertical angles are equal, and that's what we had mentioned about vertical angles. So the two angles that I just highlighted are A, E, C, and B, E, D. Take a second to trace those with your pencil. A, E, C, that's where I got that one, and B, E, D. All right, next one. Okay, we are going to do adjacent angles. Adjacent angles are angles that are next to each other. Now, there are a lot of choices for this one, okay? I'm only going to pick one. I'm going to do the two that are right next to each other, the 79 and the 48. So let me just name them. C, E, F. That would be the 79, C, E, F. And the other one is F, E, B. That would be the 48. Take a second. I want you to come up with another set of adjacent angles, angles that are next to each other. Pause the video and come up with one more set. All right, angles on a line. Now remember, angles on a line are angles that form a straight line. So I'm going to bring back my yellow sheet of paper. Now, if I put this straight, you see here's a straight line. That means that all of these angles form that straight line. So in this case, there are actually 3 angles. So I could use those 3. Let me flip. Okay, that does not form a straight line with anything. That does not go through. Here's another one. This also has 3 angles that form that straight line. So all the angles you can see form the straight line. It doesn't matter which one you choose. I'm going to do this one just because it's straight across, but it doesn't matter. All right, so these are angles A, E, C. That's angle 53. Angle C, E, F. That's the 79. And angle F, E, B. So 3 angles make up this straight line that goes across because there's 3 that we can see. All right, angles on a point. Okay, angles on a point mean they form a complete circle. So in this diagram, what forms the complete circle? That would be all angles. How many are there? 1, 2, 3, 4, 5, and 6. Instead of listing them, you can just write all 6 angles. All right, so let's apply this to actual problems here. I'm going to give you some examples where we're going to describe the relationship, and then we're going to write equations to actually solve for missing values. All right, so example 1, here's the picture. It says, in a complete sentence, describe the angle relationship. So what relationship does x and 132 have? Now, our options are listed right above. Are they vertical? Meaning, are they across from each other? Are they adjacent? Are they next to each other? Yes, but that doesn't help us with anything. Angles on a line. Do these 2 angles form a straight line? I'll bring back my yellow sheet of paper. Do those 2 angles go straight across on that yellow sheet? And that would be yes. So we're going to say angle BAC, that's this one right here, and angle CAD, that's this one right here. Okay, form a straight line. You could say that they are angles on a line. And because they're angles on a line, they will add up to 180 degrees. So in this complete sentence, you're going to write what the relationship is and what that means in terms of solving this problem. So these are angles on a line, and what that means is that they add up to 180 degrees. Okay, so let's write an equation. Now that you already have this in words, this is going to be really easy to write an equation because you've already told me they add up to 180. Well, what adds up to 180? These 2 angles. So our equation would be x, that's one of the angles, 132, that's the other angle, and they add up to 180. So here's your equation. Now this is a simple one-step equation. Okay, we're going to divide it into 2 sections. We're going to subtract 132 on the left, but whatever we do on the left, we have to do on the right. Those cancel out and you're left with x equals. Now we're going to take our calculators. You can use calculators in this and do 180 minus 132, which gives us 48 degrees. Now, after you find x, it says find the measure of BAC. So go back. Angle BAC is equal to x. Well, we already know x is 48. So there's our answer right there. Now, after you solve for x, make sure you go and find your answer for that actual angle. We are not going to use a protractor to actually measure this. We're going to do all algebraic work. All right, exercise 1. Now, before you begin this, because I do want you to try this on your own, before we do this, there is one piece of information. I was going to say missing, but I don't know that it's necessarily missing. It's just not stated directly. So, what on this diagram are we quote unquote missing? Now, if you're looking at this, we have how many angles here? We have 3, but we're only listed with 2 different measurements. This measurement is actually given. Just look at the box. Now think about what that box means. It means it's a right angle. It means it's 90 degrees. Whenever you see that box, fill that in because that's going to be a key piece of information. Now, in this problem, we have 3 angles. What is the relationship between these 3 angles? Well, these 3 angles, I'll get my yellow sheet of paper out again. They go straight across that line. They make up that straight line. So my sentence is going to be describing the relationship. So angle BAC, which is this angle right here. Angle CAD, which is this angle right here. And angle DAE, which is this angle, are angles on a line. Which means they add up to 180. All right, well, now that you have that piece of information, you can set up your equation very easily. We're going to take these 3 angles and add them together. So one of them is 3x, one of them is 90, and one of them is 2x. They add up to 180. Now, before we start solving this, notice that we have like terms, 2 terms that have x's in them. So I'm going to add those. 3x and 2x is 5x. We're going to subtract 90 from both sides. So 5x is equal to 90. Divide both sides by 5, just like you're solving an equation. And 90 divided by 5 is going to be 18. All right, now we're not done because we have to find the measure of BAC and DAE. So let's do BAC first. BAC is 3x. So we're going to take our x value of 18. We're going to substitute it in. So 3 times 18. You can take your calculator. And 3 times 18 gives us 54 degrees. Now we still have to do DAE. DAE is 2x. So 2 times 18 is 36 degrees. Now, it's not asking you to do this, but this is always a good check. If you know they add up to 180, punch this into your calculator. You have 3 angles. Do those really add up to 180? 54 plus 36 plus 90. Take a second. Put those in your calculator. Do they add up to 180? They should. All right, I'm actually going to stop there for this lesson. I'd like you to complete the homework, which is only questions 1, 2, and 3 for this problem set. You can stop after that. Just remember that when you're doing the problem set, you are writing your complete sentences, and you are setting up equations, and you are finding the missing angles. Good luck, and I will go over this again with you tomorrow in class.